It's you again, come to ask more questions on the way the world works. What is it this time? Chaos theory? Alright then. Chaos is kind of my speciality, after all.
Back in the 19th century, scientists thought they had it all figured out. They knew about gravity and the stars. They could build trains across the country and sail to America. They had classical mechanics, calculus, and thermodynamics. Things made sense. Except that really, all they were doing was creating a very broad approximation of how the world works. It worked for big things within the few big inputs involved. But for more complicated systems like the weather, or the way a wave of water breaks on a beach, they weren't even close. A few, like my ancestor Thomasina Coverley, realised that by iterating these approximations over hundreds or thousands of cycles, you would get close to modelling the truth of these complex problems. But she only had a pen and paper, and it took years to model the shape of just one leaf. Nowadays we have computers to do the thinking for us, and we can get the answers to much larger problems much faster. Iterative algorithms allow us to avoid needing to find an exact answer to such huge problems. Instead, we can make a rough guess and use that guess to improve our starting parameters for next time. So if we know roughly where the hurricane might be tomorrow, we can use that guess to improve our prediction for 3 days from now, so we can work out whether we need to evacuate that city or not. In reality, the more our ability to do this improves, the more we realise just how complicated the problem actually is, and how many things can alter our answer. Real data is messy. The famous butterfly flapping its wings is a good soundbite, but it could be any of 100,000 butterflies that has the final decisive outcome, or any of 100 more things. The action of one misfiring cell can develop into a life-threatening cancer. The clustering of a handful of atoms can create the crack that causes an aircraft engine to explode. The tiniest fractal surfaces of a leaf combine to make up its largest shape. And the turbulence of the air across mountains and oceans can change the weather thousands of miles away. And that's the nature of chaos theory. The universe is a complicated place. It's only now with computers and iterative algorithms that we can truly understand the complex ways of nature that our ancestors would only catch glimpses of.